Okay, question number 1, concept 9. Higher order derivatives, find the second derivative. You guys are getting really good at this. Let's go ahead and find the first derivative. So we're going to take 4 times 8, 32. X to the 7th plus 4 times 2 is 8. X to the 3rd, and the negative 12 zeroes out. We go one more step, finding the second derivative. So we just repeat the process. 32 times 7 is 224. X to the reduce the power by 1, get a 6. Plus 3 times 8 is 24. Reduce the power by 1, get a 2. We'll stop right there. And I see a question. Okay, number 10, I graded this one kind of soft this time. I was basically looking to see if you could estimate at least the correct sign of the derivative. So at negative 2, we're about right here. You can see the slope is going to be positive, right? Fairly steep and positive. So I was looking for some positive value there. At 0, you can see the slope of the tangent line. There's going to be negative. I was looking for a negative value there. At 1, when we go to the graph at 1 and draw a slope along that, the tangent along that, we're also going to see a negative. And then at 2, 2 is kind of fuzzy because some people think it hits right here at the bottom where you'd see a 0, and some people think it hits just around the corner a little bit where you'd see a small positive number. So I was looking for a 0 or a small positive number there is all I was doing on those. Just checking your estimates. Questions there? 11, what does F say about, or F prime say about F? It says the graph of F prime is given, and it's a continuous function. We're supposed to state the x coordinates of F where there are points of inflection. The points of inflection are the zeros of the second derivative. So how do we look at this function, this graph, the F prime, and find the zeros of the second derivative? We're looking for tangents that are horizontal, right? So it looks like there's a horizontal tangent right here. There's something going on here where it's undefined that we might want to think about. And this we don't really know much about because we can only see part of it. The only answer that we're supposed to come up with here is at 6.
So that's all it's asking.
Okay, number 4, what does F prime say about F? It says the graph of a function F is shown. Which graph is an antiderivative of F? Another way we said to ask that question was F is the derivative of which graph, right? Well, in order to look at that, we want to see where the zeros of F are, right? If F is the derivative of some graph, its zeros are going to correspond to what? Horizontal tangents, right? Well, there's a couple of them going on with that right here. It looks like there might be a horizontal tangent on the C, and it looks like there might be a horizontal tangent on the A. So then we just have to figure out which one of those is right. So we're looking at C and A. Past this point right here, though, we see positive values of F. Agreed? And on the other side of this point, we see negative values of F, which should tell us about the tangents of the original graph's slopes, the slopes of those tangents. So if we look at A, as we come out of this point, would the slopes have positive values? And as we go the other way, would they be negative? So A is still a good candidate. How about for C? As we come out of this, are we looking at positive tangents here? No, so we can throw C out. So our final answer is going to be A. Concept 12, we have to differentiate the quotient, so of course we're going to use quotient rule. So the quotient rule basically says we've got to keep this denominator where it is and square it. I turn the 3x plus 7 around. I just like having the 7x lead that if I can. And then keep that, 7x plus 3, multiply by the derivative of e to the x. What's the derivative of e to the x? E to the x, one of our favorite derivatives. Minus, this time keep the e to the x and multiply by the derivative of 3 plus 7x, which is 7. So that's a good start. If you clean it up just a little bit, you can get down to take out this e to the x in the top. There's one here and there. We can take that out. We'll have a 7x minus 4. The minus 4 comes from the positive 3 and the negative 7. That's still all over the 7x plus 3 quantity squared. That's about as far as we would want to go with that. Questions on that one? on number 6, just lost control of that thing. On number 6, we differentiate this little r of t equals 6t to the negative 3 halves. So we're just going to say r prime of t equals, we're going to take the 6 times the negative 2/3, right? And then we're going to keep the t, and then we're going to reduce that power by 1. So negative 2/3 minus 1 is the same as negative 2/3 minus 5, or 3/3, which is negative 5/3. So 6 times negative 2/3 turns out to be negative 4. So it's negative 4t to the negative 5/3. Questions there? 13, questions 7 and 8, we just have to use the product and or quotient rules. For number 7, we're differentiating a quotient, so we're going to go ahead and use the quotient rule again. We'll keep the denominator and square it. We'll start with the denominator in the numerator, multiply by the derivative of the numerator, which is 4, minus, keep the numerator, 4x minus 7, multiply by the derivative of the denominator, which in this case is 2. And then it's just a matter of cleaning it up from here. If we distribute the 4, we get 8x plus 12. I'm going to think of this as if the 2 were here, and distribute a negative 2. So that gives me a negative 8x plus 14. A lot of you guys missed this sign right here. Plus 14 all over 2x plus 3 quantity squared. 8x minus 8x zeroes out. The 12 and the 14 makes it 26. Any questions on this one? We had one more to do. Number 8. We've got a product, so we're just going to go ahead and use the product rule. I kept the root x, multiplied by the derivative of the 5x squared minus 3, which was 10x, plus, then I kept the 5x squared minus 3, and multiplied by the derivative of root x, which is 1 over 2 root x, and then took a look at that and said, well, how can I simplify that? Well, I see root x times 10x plus 5x squared minus 3 all over 2 root x. I see addition of fractions. The only way I knew to do that is to get a common denominator. The common denominator in this case is not a pretty one. It's 2 root x. So if I'm going to multiply top and bottom of this fraction by 2 root x, the 10 is going to become a 20. What's root x times root x? X times the x that's already there is an x squared. So that's 20x squared, which simplifies to 20x squared plus 5x squared is 25x squared minus 3 all over 2 root x. So some of you guys actually got down to something that looked like this, but a lot of people just said this is good enough right there. And I did not argue with you. Questions there?